Welcome to the second QuickBits video on hardcoding. In this video we're going to go over what hardcoding is and why it's bad and how we can avoid it. So on screen we've got a classic example of hardcoding. We're creating a list of a hard-coded value 10 and we're going over that list first to find the even numbers and print them out, and then to find the odd numbers and print them out. And the hardcoding part is that we say make it size 10 here, and we loop over 10 again over here and 10 again over here. So that's the hardcoding itself. Now why is it bad? Now let's execute our code and look what it gives as a result. So let me create a little bit of a clean screen. Alright, so this is the output of the code we made, and as we see all the numbers from 0 to 10, which we create over here and print over here, and we see the even numbers from this loop and the odd numbers from this loop. Now because it's hard-coded, if I would want to change the size of our list and add more numbers, let's say 20, and then execute our code, the rest of our code won't update and the even and odd numbers will still be going over only 10 elements of the list. So the way we fix this and prevent this is by either using a variable name for the size and using that everywhere, or picking maybe a constant variable name for the first size and then using the length of the list as a dynamic size for the for loops. So let's go ahead and make those changes. So we'll create a constant called list size. We'll say that set that equal to 20, or let's set it equal to 10 for the initial test, and then we'll replace all these values by the list size, and to go one step further and make it only dependent on the list size in real time. So if we would filter the list and say make the list only contain even numbers, then it would still work in the code below. So let's make it dependent on the length of a list. Perfect. Okay, so we create a list of constant size 10, and we create the list and then we go over it. So let's run the code. We see I spelled something wrong. Oh, I don't know why I typed list here. It's supposed to be length. So let's run that again. Perfect. We get our output for a size 10. And now the only thing I would need to do to change it to size 20 is update this constant at the top. And if we run the code, we see that everything works for 20 numbers, and we get the even numbers up to 20, as well as the odd numbers up until 20. Alright, one last thing to spice up our code is we can remove this range length of a list, because it's better practice to use enumerate, and most often it's actually faster, especially if you're going over a large amount of numbers. So let's update this to be enumerate over a list, and what enumerate returns is the same I, which is the index, as well as the element inside the list. So maybe I'll call it num because it's a number. Alright, and we can do the same below. Perfect. Let's set our list size back to 10 and execute our code. Alright, so it seems to work for a list of size 10. Now let's size up the list and see if the program dynamically changes. Perfect, so it works for 20 as well. So as you see, we now know how to identify what hardcoding is, and we also know how to prevent and solve it if we see it. Hope you enjoyed the video. Please like and subscribe if you did, and check out some of my other content. I personally really like the Folium series about how to create maps in Python and how to inject JavaScript code to make those maps interactable in the browser. Alright, have a nice day. Peace.